I'm right here to take you through chemistry practical. We are going to do a practical that is actually common but rarely taught. We have here a simple question that we are going to go through, and the question is very simple, like we shall confirm at the end. So the question goes, Bukola is a fertilizer manufacturing company which manufactures various fertilizers by reacting acids and alkalis. The Ministry of Agriculture has insisted that the proportional volumes of the chemicals must be mixed in order to avoid one being excess, which may damage plants and soil. The manager of this company has been advised to take a lot of care when mixing the chemicals, and therefore he must determine the exact volumes of each solution to be used, but has no idea on how this is done. If you have been contacted by the company manager for help and they have provided you with, so we have here solutions BA1, which is a solution of dilute sulfuric acid, and BA2, which is dilute ammonia solution. So we have BA1. Here is our BA1. This is our solution BA1, and this is our solution BA2. So we have the two solutions, BA1 and BA2. So the intention of the set of the item told us that in the confidential that we provide you with all these things you see here, plus these ones here. That on your table, we include all these ones you see. A bullet, a retort stand, 4 beakers of those sizes like you see them. 4 measuring cylinders like you see them. A thermometer, a stop clock or stopwatch, and 2 beakers plus a conical flask. I'd forgotten to put it there. Plus a conical flask. So we have everything the set of the item told us to provide. Members, we are here to go through practical techniques. We are going to learn practical techniques. I think I put this one aside. And whatever is provided here, not everything is to be used in this practical. So when we read through this item, they are telling us to determine the exact volumes of each solutions. We have two solutions, BA1 and BA2. So we can decide to make it as our aim. So this is part A, the aim. So they are telling us the company manager was told to know or to make sure that he determines the exact volumes of each solutions to be used to make the other fertilizer that it does not affect the plants or soil. So the aim of the item will be to find out the exact the exact volumes of BA1 and BA2. When you read it through the scenario, they are telling us that can be reacted so as to form a fertilizer that cannot damage the plants or soil. I think that was what was given in the scenario. Members, from the previous theory I've been going through, I talked about the hypothesis, though indirectly. These kinds of reactions, I've told you that as the acid reacts with the alkali, there is bond formation. And we've said that these kinds of the bond formation results into giving out of heat. And the heat is always determined as temperature. So to cut the story short, the hypothesis we said an hypothesis is simply a theoretical prediction of results. So I may say as BA1 reacts with BA2, heat is given off. That may be my hypothesis. There are many ways of skinning a goat. Someone else may say the reaction between BA1 and BA2 is exothermic. Someone else may say that heat is given off as acids react with bases or reacts with alkalis. So there are many ways of skinning a goat, but an hypothesis is simply a theoretical prediction of results. The variables members, the controlled variables we said a controlled variable is the one that is going to be kept constant within the investigation. So we said we are going to use fixed volumes of the alkali. So we are going to make sure that we use the same volume, the fixed volume of the alkali, and the alkali here is BA2. So that means the controlled variable will be the volume of BA2 used. And then the independent, so the independent variable members is simply the quantities that are going to be changing so that we can get results. What we keep on changing so that we can get results. We saw we are changing the volumes of the acids added. We started with 0, we added some 5, recorded the temperature, we added more 5 to make it 10, we recorded the temperature. That means that the independent variable is going to be the volume of BA1, because this is the acid used. And then the dependent variable, will simply be, we said as we add the acid, what were we doing? We are recording the temperature of the reaction, the temperature of the mixture. So the temperature of the mixture becomes the results, or the dependent variable. I think we are flowing. Members, the apparatus or requirements what are we going to use? As I was narrating the practical, how this is carried out, we talked of a fixed volume of the alkali we are to use. So, which apparatus measures exact of fixed volumes of solutions? I think that is a pipette. So, we shall need one pipette purposely to measure BA2. We talked of a plastic beaker because when we use a pipette to transfer the other fixed volume, we always put it in a plastic beaker. So we shall need one plastic beaker. Why are we using a plastic beaker? We are going to use a thermometer to steer. So something plastic will not damage our thermometer. 2, plastics are usually poor thermoconductors. So it will not conduct the heat generated away or bring in the heat from the surrounding. So we usually use a plastic container to minimize heat gaining or loss. To continue, we saw we are going to be running uniform fixed volumes. I lapped them off. Fixed uniform volumes of the acid, which is BA1, onto BA2 in the beaker in intervals. So that means we are either going to use a bullet or use a measuring cylinder to transfer those standard volumes. Alternatively, still here, we may use a measuring cylinder instead of a pipette. Because a measuring cylinder, it can as well measure standard given volumes. Because it is graduated, it has a scale here. So we shall, from here I'm going to use a measuring I'm going to use a measuring cylinder. And finally, I will need a thermometer. The thermometer is purposely going to be used to determine the temperature of the mixture. I think we remember the procedures I recently stated. We remember the procedures, I think. Do we? We said some people start with one putting on protective gears, gathering all the required apparatus onto the table. We may not write that. We may not need that. So our first procedure, we said previously in the previous explanation, we said we first of all transfer a standard volume, a fixed volume of the alkali into a plastic beaker. So that will be our first procedure. For me, I'm going to take 20. 20. Members, a measuring cylinder records its values to 1 decimal place. For me to be accurate, I'll rate my values to the standardly known number of errors. So 20.0 cubic centimeters of BA2, where I'm using this tense because I'm reporting what I did, though I'm explaining now. So remember, the procedures must be written in a reported format and in past tense. Were measured using a pipette and transferred into a clean, empty plastic beaker. So this is my first procedure. We say the next procedure, we are going to use a thermometer to determine the temperature of this solution of BA2 in the beaker. The temperature of BA2 without the acid was determined using a thermometer and recorded. So this is now the temperature reading when 0.0 cubic centimeters of the acid is added to BA1 to BA2. So the next procedure, we say we are going to add equal volumes or uniform volumes of the acid at intervals while stirring and determining the temperatures of the mixture. For 7 values until when the volume of the acid added is let's say 30 cubic centimeters. So it's what I'm going to write. Uniform let me put it more clear. Let me write it this way. 5.0 cubic centimeters of BA1, where I'm going to use a measuring cylinder. I'm not going to use a bullet. I'm going to use a measuring cylinder of 10 cubic centimeters. So 5.0 cubic centimeters of BA1 were measured using a measuring cylinder and transferred onto BA2 in a beaker, mixture was stirred and the new temperature of the mixture was read So what we do, we measure 5 cubic centimeters of BA1 into the other solution, BA2, of fixed volume in the beaker. We stir the mixture, read the temperature after giving it time. Let's say a standard time of 1 minute for every interval. So stir the mixture and then we read and record the new temperature. So we shall be reading it from the thermometer. That's why I'm mentioning was read. Members, the apparatus must be stated was read from the thermometer and recorded. So what we shall do, we shall be repeating this procedure of adding the acid for all these kinds of practicals, whether determining heat of reaction, heat of neutralization, or determining the volume, the unknown volumes of the acids and bases reacting. We shall be repeating this procedure of adding the acid using uniform volumes of the acid. We shall be adding to the other solution, to the other 5, where we added the 5 cubic centimeters of the A1. We don't power off the solution or the mixture. We keep on adding uniform volumes of the acid. We add more 5 to make it 10 cubic centimeters. We stir, we repeat whatever we did in this procedure. We stir, we record the new volume. I think I'm clear. I mean, the new temperature. From the thermometer, we add more 5 to make it 15. We stir the mixture. We are not powering the solution, we are maintaining the solution of the alkali we used, but varying the volumes of the acid. We add at every interval. So we add more 5 to make it 15. We stir again. We read the temperature from the thermometer and record it in the table we shall be making. We add more 5 to make it 20. Stir again. We are repeating whatever we did in this procedure C. We add more 20 in the plastic beaker where we have BA2 and some acid that was added. We stir using a thermometer, give it time, read the temperature from the thermometer and record it. So make sure that we repeat those procedures, adding uniform volumes of the acid at intervals, reading the temperatures until when we make about 7 values. I think I'm clear. Members, to make time not an independent variable, we may decide to make time taken for each reading of temperature to be a controlled variable. To make sure that if we take 1 minute to read the value of temperature after adding 5 cubic centimeters of BA1, we take the same 1 minute for reading when we add more 5 to make it 10, we take the same time, 1 minute, like that, to make 15 cubic centimeters, to read the temperature. So we can add still temperature, time taken to read temperature of the mixture. We may make it a controlled variable, not to make it a factor. So that will lead us to results, and among the results, we shall be having the volume of BA2 used. We have it. From here, I decided to use 20 cubic centimeters. I'm going to use a pipette of 20. I may alternatively use 25. It's your choice. You use the volume of your choice. So for me here, I used 20 cubic centimeters. Remember, a measuring cylinder records its value in a decimal place. So next, I will have a table. A table that will include the volume of BA1 used. And remember, volume is recorded in cubic. We are going to use a measuring cylinder. So I will record my values in cubic centimeters. And I will have the temperature of the mixture. And members, temperature is read from a thermometer that records its values in degrees Celsius. So I think I will have a table of these ones. I have where the first value when I added 0.0 of the acid, where I added 5.0 of the acid, where I added 10, where I made it 10.0 of the acid, 15.0 of the acid, where I made it 20.0 of the acid, 25.0 of the acid, and the table is continuing for these values we recorded. So my table will be ready, and at this stage, I didn't write the risks and mitigation. They are simple. You can get any one risk, possible risk, and its mitigation. You can even put them in the comment section for other friends of yours to know them. So my work is now ready. This is my planning stage. I'm ready to use the apparatus. All what I've been doing was the theory coming from my head, not using the apparatus. Without this done, the use of the apparatus will not be possible, because I will have nowhere to put my results of what I will be getting after using the apparatus. So the first procedure, we are transferring 20 cubic centimeters of BA2. So this is my BA2 from the start. Remember, I'm going to measure 25 cubic centimeters. I'm not using a pipette, but if you decided to use a pipette, please use a pipette. So I'm going to transfer 20 cubic centimeters of BA2 . So according to me, this is my 20 cubic centimeters. I'm transferring it into a plastic beaker. We said the second procedure, we are going to use a thermometer to determine the temperature of this Ba2 without the acid. So from my readings, I'll give it time until when the thread of the alcohol in the capillary tube is stable. And it is reading, it isn't moving anymore. It is reading 24, that red thread. It is reading 24 degrees Celsius. So my thermometer reading without the temperature of Ba1, the temperature of Ba2 without Ba1, when 0 of Ba1 is added, is 24. Members, a thermometer records also its values to 1 decimal place. So my thermometer reading is 24.0. So I'm going to go to my next procedure where I'm going to add 5.0 cubic centimeters of Ba1. So I'm going to measure 5.0. I'm going to use this measuring cylinder. So this is my 5 cubic centimeters of Ba1. I'm transferring it into Ba2 in a plastic beaker. Stir the mixture gently using a thermometer because it is part of the procedures, stirring. And I'm going to give it time for the reading to be stable. So you can use a stopwatch to make sure that the time taken for you to read the temperature is standard. It is fixed for all the values you're going to make, for you not to make time an independent variable. So to me here, the thermometer reading is becoming stable at 28. Camera can come closer. I think that is 28, between that and I think that is 28. So I will record my temperature. So my temperature is 28.0. When I add, so I am going to repeat the same procedure C. I'm going to repeat it. Again, adding a uniform volume, the volume I added at first, that was 5. Still again. So I'm adding more 5 to make it 10. So I'm going to measure 5 again. So I'm putting 5. Steer. Start your stopwatch. Make sure that the time you take for you to record the temperature is the same time you took before recording the other previous temperature. My new temperature here, so I'll give it time for the reaction to occur or to proceed. And then I'll be reading the standard the new temperature. And I'm seeing the new temperature reading here is a 30. Camera may come close. I think it is clear. The new thermometer reading is 30. When we made 10 of the acid added, we are going to add more 5. Repeating the procedure, we are going to add a uniform volume we added previously, that is 5, to make it 15. We are using the same mixture, same solution of BA2. So we are adding BA1 uniform volume, that is 5. But this practical is very simple. So after adding, I stir, so I've made it 15 now. I will stir gently and then give the reaction time to proceed. So the reaction, the new volume, the new temperature reading is stably stopping at 31. Or 30.5. I think you've noticed it. 31 or 30.5. So I'm going to add more 5 again to make it 20 this time. We are going to measure more 5. So stir the mixture using a thermometer. Ensure uniform mixing of the two. Give the reaction time to proceed. Remember, I started the stopwatch. Or you wait until the thread is not moving anymore. Here is my reading. It is stably stopping at 29. 29. So my new reading is 29.0. I'll add more 5. I think the practical is cheap. It is very simple. And when you find this of this kind, please let it not be a hassle to you. Don't forget to subscribe so that you can get more and more of these kinds of practicals. Don't forget to tap the bell for more notifications. Don't forget to invite your friends. So I'm adding more 5. I think we see the trend. I'm stirring. Remember, the temperature was increasing until a certain value, it started dropping. So it was 31 and it is now dropping to 29. So here's I'll give it time to proceed, but don't forget to share, to give your contributions of the risks and mitigations in the comment section, to like if you really like what we do. And my thermometer is stably stopping at 28. You can come and check. It is stably stopping at 28. So on adding 5 to make it 25, it stopped at 28. Members, I'm adding a decimal place after the decimal point because a thermometer records its values to an error. And you continue doing that for these other values when it is 30 and 35. We still have the solutions. We still have BA1. Let's add more 5 to make it 30. So I've added more 5. So I'll stir the mixture. Stirring. I'll give the reaction time to proceed. And members, my new temperature is stably stopping at 27. We can check. It is stopping at 27 for 30. So we keep on repeating the procedures until it is 27. I think it is seen. We repeat the same procedure after adding more 5. So we are adding this uniform volume of the acid at intervals, stirring, recording the temperature. So members, the values we obtain, we shall go down, like in this paper, we are given space for a graph page, a graphed or squared page. Members, we shall use this one in this paper. For example, in this paper, we shall use this squared part to plot a graph of temperature against time. I mean, a graph of temperature against volume of the acid added. To look into this, we shall have, briefly to go into this, we shall plot a graph of temperature against volume of BA1 used. When you look at the values, if this is temperature and this is volume of BA1 used, we shall have, let's say our starting value of temperature is 0. We plan, we are recording temperature, this temperature here. No, our smallest value for temperature is a 24. Let's say we may take it as our starting point. So we may take our this, let's say 22 as our state, 22.0 becomes our starting point. So we can look for the intervals, the scalar differences How many degrees are we going to be adding? Each value, it should be uniform. We are going to get time of plotting these kinds of graphs, how to get a good scale, how to know the scale differences if you don't know this. But those with some knowledge of plotting a graph, when you plot this kind of a graph, now this is the volume of BA1 used, until when we get to the maximum volume of BA1 used. So we shall have a graph. We have the 24 somewhere with the initial temperature of this one. With the initial volume of 0, we shall be having values plotted, and we shall have kind of a curve. If you look at these values well, if this is temperature, we shall have a curve. 31 somewhere for this value of volume. And as you continue with the adding the acid, as you continue adding the volume to 20, 25, 30, 35, we are seeing the temperatures decreasing. So we shall have a decrease as you add more of the acid. So we shall have a curve. I think it is even evident in the results. So after getting the curve, we shall get a ruler, draw a tangent touching our curve on this side, and another tangent touching the curve on the other side. And then look at where these two tangents meet. Get your pencil and a ruler, make a dotted line downwards towards the volume axis, and this volume X on your scale will be the maximum volume of BA1. You try to plot this graph. Whoever is watching, try to plot this curve. Share it with your friends in the in the WhatsApp groups. And if you're not part of the WhatsApp groups, it is simple. You check us on our WhatsApp number, which is 0703 278 231. That is our WhatsApp number. You can reach out to us and join in the group. The community is there with a good number of students, always sharing. Members, so we can take this as our maximum volume of BA1 that should be added to the other 20 of BA2 so as to make a fertilizer like it was in our aim that cannot damage the plant soils and the plant and soils. If the practical was to determine the maximum heat evolved, we could use this, we could as well determine the maximum temperature. So we make a dotted line towards the temperature line side or axis, determine this temperature Y, and use it in the other formula, MC d theta. So this standard maximum volume would help us to get the mass. So we use this standard volume here to get the mass. Remember, the mass density is mass over volume. So this means the mass is volume times density. The density is usually 1 for solutions, and the volume is the one you determine here. The standard temperature we use, or the maximum temperature, is this one in the theta. I think we are following. So this practical, our major aim was to determine the maximum volume of each solution. So we have the maximum volume, the volume of BA1, BA2 we used was 20, and the volume of BA1 that must react with 20 cubic centimeters of BA2 is this volume you determined here. So you go in your paper where they told you, you go into your paper where they told you to make a deduction using your findings, you will just go into this and say, therefore, for every 20 cubic centimeters of BA2, the company manager should add this volume of BA1 so as to make a fertilizer that will not damage the plants or soil. So this is according to this paper. Don't forget, members, we are determining the maximum volume or the exact volumes with these kinds of procedures. I'm to online. Don't forget to subscribe, to invite your friends, to share with others, to like the videos if you really like them, to tap the bell for more notifications. Teacher Alan.